Hey guys, good afternoon. So my name is Alosh. I'm an AI engineer and a researcher, part-time hobbyist as well. And I know it's almost time for lunch, so you guys might be hungry, but I'll keep it as short as I can. So I'll be exploring transparency in LLMs, basically trying to use open source tools to peek into the reasoning happening under the hood of different large language models. So this is usually what happens when we have a conversation. We don't know what's going on in the person's head. So I don't know how you guys are feeling about this session, and you guys probably don't know what I'm thinking about when I'm speaking out to you guys. But what we do know is what comes out of the mouth is probably the reasoning of what happens inside your head. And the same is the case for LLMs. So we never really see how LLMs think. We only see the response. We never really know, like, okay, what are they thinking about? Are they thinking in English or in Hindi or in Kannada or Malayalam? We'd never know that. And the reason is because LLMs are a complete black box, and all we know that under the hood they look like a bunch of neurons. And the question that's always struck me is what's inside the box. This scene, you might know this from the movie. I don't know how many of you guys know it. Okay, yeah, there are some people. It's a very dark scene. But yeah, the question is what exactly is happening inside this black box? So just a simple question to the audience. What's the answer to 13 times 13? Okay, could someone explain the reasoning for that? Anyone? Okay. Let's assume this is a second grade math class, and I'm asking you to multiply these two. 3 threes are 9. Okay. And then 13 apples 13 times. That's what he said. Okay. That's it. That's it. Okay. Tens place, same thing. Okay. So I've got an idea of how you guys are multiplying 13 times 13 in second grade, but now I guess it's all a guessing game. So in LLM, it's the same thing. We ask it the same question, what's 13 times 13? It gives us the answer as 169. But we don't know what's happening under the hood. It's a complete black box. We don't know what the neurons are thinking about it. But what we can assume is that it thinks in almost the same way that we thought. So let's say it's going to think, someone said 3 times 3. So it will multiply 3 times 3. Then it's going to multiply the tens place. And it thinks that, okay, it's somewhere in the vicinity of 100. And then it's supposed to be a square root. So that is greater than 100. And so it guesses, okay, so it's a number that ends in 9. And it's supposed to be a square. It's greater than 100. So let's guess 121, 144, 169. So what happens under an LLM is that it's a complete guessing game. But we need to peek further beyond guessing to see what really happens. And that's where something called circuits comes in, not your physics circuits, but circuits in reasoning. And in fact, this is an actual LLM's reasoning circuit. It traces the exact path of how LLMs think. When you ask it a question, what are the exact regions it goes through? What does it exactly think about? And where does it concatenate all this information to give you a solid answer? And we can also trace the circuit of reasoning in vision models. So for example, this is CLIP. CLIP is OpenAI's vision multimodal model, and it thinks not in terms of text, but in terms of images. And when given the word India, this is what its neurons thought about. So it's all pictures of, you can look at the faces, look at the logos, the architectures. It's all very sort of akin to Indian architecture because it's learned on this data. And if you were to give Bangalore, it would probably give something like this, just my assumption. Traffic, the food, Uber, all that stuff. Transformer Lens is an open source library. It's a tool to peek into how LLMs think. And it's pretty apt at just breaking open the LLM and seeing how it thinks. Another question. In what year did World War II end? 1945. So some of you know about it because you've learned about it somewhere. But from an LLM's perspective, when we ask it the same question, it thinks in different formats. So for each option, it creates 3 different paths. And one of these paths has the highest probability of being correct. And boom, it selects 1945. Now, how do we see this? How do we know that it selected 1945? Not because it was trained on it, but because it was able to think with precision that it was correct. And that's what transformer lens does. And just to get a bit technical, this is an attention heat map that shows us how relevant different words are. So the more yellow the words or tokens are, the more relevant they are. The more blue they are, the less relevant they are. And this is sort of like a low-level view of what transformer lens gives us. Now remember the India-Bangalore scenario. So that's a vision-based approach. So we have Prisma 2. It's an open source tool for visualizing neurons for multimodal LLMs. So for example, this is an image of a cat. And an LLM can accurately identify it as a cat, of course. You can see these little emojis in the second picture, right? So that's the LLM like pointing out like this is a cat and this is not a cat. So when you use Prisma, Prisma goes into each layer of the large language model and sees the output. So in layer 0, it's a complete mess. It doesn't identify cats. If you go to layer 7, it's trying to get a sense of the picture. And as we progress and reach the last layer, it's able to find out that, okay, the LLMs is spotting this as a cat. Now, towards the end of this session, you guys may be having these thoughts, like I've talked about circuits, some lens stuff, prisms, but what might be coming out of your mouth is maybe it's cool, it's awesome. So what if you're able to be like this guy? You might know him, X-Men, Charles Xavier. So we don't have like an open source version of this guy yet, but maybe if Neuralink is successful, we'd be able to tap into people's heads and see what's happening inside. But sadly, fortunately, we only have the resource for looking into LLMs. And that's the end of my talk. And I just want to shout out to Tinkerspace, who have been generous to provide me a GPU to test out transformer lens and Prisma. And if there's any questions from your side, I'd love to entertain them.